In the last lecture, we finished chapter 1. We now have chapter 2. Chapter 2 is 3 parts. It's 3 parts. The first part is about relations. We talk about relations on sets here in this chapter, in this section of chapter 2. See, the most basic relation is equality. For example, x equals y. This is a relation between x and y. It's a relation between x and y when we say x equals y. And also we have binary relation. So it is a subset of Cartesian product of two sets. Here, we always write down the product of two sets as a as a Cartesian product. Okay. Here we have an example A and B. We say if A and B be two sets. Then we have a relation R. R is the relation on the sets A and B. We say XY is in A times B or A cross B. This is the Cartesian product of these two sets. We say XY, all the elements in the Cartesian product is in this form. XY in A cross B. And here R is the relation, is a subset of A cross B. Or you can say X related to Y. We say X related to Y if and only if XY is in the relation. We'll talk about this by examples. It will be much clearer. We say if XY in R, we have X to be in A and Y to be in B. It could be written as X related to Y, and read as X is related to Y. When you write down X, R, Y, R is the relation between X and Y. We say it reads as X is related to Y. We say if X and Y doesn't belong to R, if XY, if we have two points, or if we have a member in the Cartesian product which is not in the relation, where X to be in A and Y to be in B, it could be written as X doesn't relate to Y, or you say X is not related to Y. It's just some basic things about relations, how to read it, and that's it. Here we have relations on sets. So to show relations, we can use one of the following options. Yeah, we can express a relation between two sets by these 3 ways. Okay, first, using the traditional notation. Yeah, we say 0 is less than 1, and 0 is less than 2, 0 is less than 3, 1 is less than 2, 1 is less than 3, and 2 is less than 3. This is a relation that X is less than Y. Yeah, X is these values. X take these values, and Y takes the other ones. This is a way for expressing a relation between two sets. And we also can write down as this form. This also is the same as that one. Okay, we can express the relation either in by this way, by the first one, or by the second one, or by the third one. Here we say R is the relation. R is the relation. In the relation, what we have? We have 0 and 1, 0 and 2, 0 and 3, 1 and 2, 1 and 3, and 2 and 3. We have these members in the relation, but we have no 3 and 1. We have no this member in the relation. As you see, the relation here is the first element is less than the second one. The relation here in R, as you see in R, always the first member is less than the second one. 0 and 1, the first is less than the second one. 0 and 2, and so on for others. But here 3 and 1, In this one, we say 3 is bigger than 1. So the first one is not less than the second one. That's why we say this member doesn't belong to the relation. And we also can express that relation by using this diagram. We say 0 related to 1, to 2, to 3. That means we have arrows which goes from 0 to those 3 numbers, 1, 2, and 3. As you see, we have an arrow from 0 to 1. We have another one from 1 to 2, 0 to 2, and from 0 to 3. We have these 3 arrows which arises from 0 to those 3 numbers, 1, 2, and 3. And also we have two arrows which goes from 1 to 2 and 1 to 3. That means we have 2 arrows arise from 1. One goes to 2 and the other one goes to 3. And you have only 1 arrow which goes from 2 to 3. That means you have only 1 arrow from 2 to 3. That's another way for expressing this relation. So you have these 3 types of expressing the relation. All are the same, okay? All are the same. You can express by either this way, or that one. We have these 3 ways for expressing a relation between 2 sets. Skip this example because it's about states. It's about states and states. None of us, may not all of us now, which state is in which states. That's why you will not see any example like this in exams. So skip this one. Skip this example. Here we have an example. We have A and B, which are 2 sets. A is 1, 2, 3, and 4, and B is P, Q, and R. It says define a relation S. That means here we have S as a relation from A to B as follows. S equals 1 and Q. That means 1 is related to Q, 2 and R, 3 and Q, 4 and P. Here, if you find the cross product of these 2 sets, let's see what we get. The cross product of A and B, we say A times cross B equals. It equals what? Each of these members should relate to all members of the other sets. That means we have 1P, 1P. We also have 1Q, 1R. And for 2 should relate to P, Q, and R. And we have 2P, 2Q, 2R. And then for 3 and 4 also. We have 3 in P, 3Q, 3R, 4P, 4Q, 4R. Here, these are the members of A cross B. Always the relation must be in the must be a subset of A cross B. As you see here, S has only 1, 2, 3, these 4 elements. S has these 4 elements. 1 to Q, 2 to R, 3 to Q, and 4 to P. Let's see if you can find these all in A times B or not. Look, for the first one, we have 1 and Q. So we have 1 and Q here. If you can find all elements of S in A times B, that means we can say S is a subset of A times B. We found A times B before. Then 2 and R. As you see here, we have 2 and R. That's it. We found these two. 3 and Q. This is 3 and Q. I also have 4 and P. We have 4 and P. As you see, we could find all elements of AS, which is the relation, in the A times B. جانتاك اللعبة موبايلك الشركة كل دي بدأ السكيت تهلا. كواتا ليرة إما علي A times B ياخد A cross B شيء بريتل ديكارتي همو ميمبركاني دو ست يكم ورقم A times B هيا يك ميمبركاني ست يكم لقل همو ميمبركاني ست دوام بشو ديكارتي باشا أما كروس أي ليرة ريليشن كتشي تعريفك ليه بيناسك الريليشن كل بيناسك معناته ليرة بيناسك بوشي ويالشي يك relatable Q دو relatable R سيبو Q شواربو P كواتا ليرة هميشة أو ريليشن كهمانا أبيت سبسيتك بلشي لكروسي دو سيتك أبيت سبسيتك لكروسي دو سيتك كواتا سيركين ليرة شي مانكر كروسي دو سيتك كمان دوزيوا أما تنها بوي كبزان بوشي أوني سبسيت اللي هو بوي أو دوزيوا جان بيس ناكا عادي كروسي دو سيتك كمان دوزيوا كدوزي معنا وسيركين همو ميمبركان يسكو تناو كروسكو كوتناو ليدانكو ليك دانكو كواتا تو is بلين is a subset of A times B. Look, it says is 1 related to Q? Look, we are gonna look S. If we have 1 and Q, that means the answer is yes. That means 1 is related to Q. Do we have 1 and Q? Yes. Then now, relation kaya agarin bochi yakun Q. Zan yakun Q hit tiaya. Balatia. Kawata wala makaman yes. In the second one we have is S is 3 related to P. If we have 3 and P, means the answer is yes. But if we have no 3 and P, the answer is no. Okay? In S, we are going to look for 3 and P. We can't find 3 and P. That means the answer is no, because 3 is not related to P. It says in this example, we have it says define a relation L. L is the relation. In the previous example, the relation was S, but now the relation is L. From R to R. R is the set of all real numbers. This is the real numbers. R is the set of real numbers. That is all the numbers, all the real numbers. From R to R. As follows. For all real numbers, X and Y, we say X is related to Y if and only if X is less than Y. That means if any two real numbers satisfy this equation, this inequality, I mean, it means X is related to Y. X and Y are real numbers. Just if you pick two real numbers, let's say 3 and 4.2. Is 3 related to 4.2? Let's check. If this is X, this represents X, and the second one represents Y. That means is 3 less than Y, I mean 4.2, is these two numbers satisfy this, 3 less than 4.2. Is it true? Yes. Amarasa bale. Labari piyonde kama bchuktira. Labari piyonde kama bchuktira. Kawata lera ani hardu real number yak. دانا قبل الريليشن كمان اگر x نرخب تشوفه كاول. Okay, here we have these examples. We have these 4 examples. It says is 57 related to 53? It must satisfy that 57 is must less than 53. Is it true? No. because the relation is less than. Our relation is less than. So it means the answer is no. Why? We say since 57 is bigger than 53. It's not less than 53. The first one must less than the second one. Then it's in the relation. We have minus 17. It says is less than minus 14. Is it true? Yes, that's true. So you see, yes. For the third one, 143 L, I mean, related, is it related to 143? No, because none of the real numbers is less than the number itself. Okay. If the relation is less than or equal, so this would be true, because here we have equality also, but we have only less than. That's why we say it's not true. So this is not true. Or we can say no, it's not a relation. Why? Because 143 is equal to 143. This is not less than 143. Is negative 35 related to 1? Yes. That's it. The answers are simple. Here we have another example. It says define a relation R. Here our relations are. In the previous example, our relation was L, and here it's R. From Z to Z. Z is the set of integer numbers. Integer numbers. This is the set of all integer numbers. It says Mn belongs to Z times Z. We say M is related to N. If M minus N means if the first one minus the second one is an even number. That means if we subtract the second from the first, we get an even number. Let's see, here we have these examples. It says, is 4 related to R, related to 0? We say 4 minus 0. What's the result? Is 4. Is it even? Yes. So the answer is yes. Look, the definition is M minus N means the first one minus the second one must be an even number. So if the result is an even number, we say the first number related to the second. So this is yes. How about the second one? Look, 2 minus 6 equals minus 4. Is it even or odd? Or none? That's even. We have even positive numbers and even negative numbers also. So that's true. So the answer is yes, it's even. So it's yes. This is a relation. I mean, 2 is related to 6. How about this one? 3 is 3 related to negative 3. Let's see. We have 3 minus 3. The second one is negative 3. We must subtract minus 3 from 3. And we get 3 plus 3. Negative becomes positive. So it's 6. So it's also even. The answer is yes. How about the last one? We have 5. Is 5 related to 2? 5 minus 2 equals 3. It's not even. So it's no. We say 5 is not related to 2. And here it says list 5 integers that are related by R to 1. That means, let's say X related to 1. Give 5 different values to X to satisfy this. Later, على بينج جماعة people ك relating بيكوا وتا أجر يكين ليدر بكم even there is no. هر جماعة أودور قري راس. هر جماعة كواتا زو infinite جماعة ما هي. على بينج تاني people. قاعدة شي دابلين شمارين بيبل 5 yes then 9 we can say minus 11 it's true also because minus 11 minus 1 is minus 12 which is even and so you say 1 oh we can say 1 let's say 12 so 13 and one more let's say 25 these all are satisfied the relation. That means if we replace x by any of these, we get an even number. If we subtract 1 from these all, we get an even number. That means these are 5 numbers which satisfy that if they are related to 1. I mean here. So how many more numbers do you have to satisfy this? Infinite. You can pick any odd number. If you pick any odd number, it satisfies this relation. Look, let's solve it here. Now we have domain and range. What's the domain and what's the range? We say the set of all the first elements, the set of all first elements in the relation, the set of all of them is called domain. And the set of all second elements is range. Here, if you have here, it means A is related to B. That means all A's, the set of all A's is domain. وهمون الحكاية كم؟ أبنى domain. وهمون الحكاية دوم أبنى شيء range. أما domain or range here. Look, here we have X, which is 1, 2, 3, 4, and you have a relation on X such that X is less than or equal to Y for all XY in X. That means we are going to pick both X and Y from the set X, from this set. Let's see, in this set, we must pick any two numbers which satisfy this one. X to be less than or equal to Y. Can I pick 1 and 2? Is that satisfy this condition? 1 and 2. Is 1 less than or equal to 2? Yes. How about 1 and 1? Yes. How about 2 and 2? Yes. 3 and 3? 4 and 4. And then we have 1 and 2, 1 and 3, 1 and 4. These all are satisfy the condition. Then 2 and 3, 2 and 4. And we also have 3 and 4. Do you have any other number? Any other two numbers will satisfy this condition? There is no any more numbers in the set A, in the set X, will satisfy the condition. The condition is X is less than or equal to Y. That means the first number is less than or equal to the second one. So these are the elements of the relation. This is the relation. As you see, this is the relation. And then what's the domain of this relation? What's the domain of this relation? 1, we just pick any number once, okay? 2, 3, and 4. We have these 4 numbers as the first elements. That means domain equals 1, 2, 3, and 4, which equals to X itself. Is it? How about the range? For the range also, we just pick any number once. We have 1, we have 2, we have 3, we have 4. This is repeated. This is all others repeated. So the range is 1, 2, 3, and 4. It equals to X. That means both domain and range are X. Yes. Sorry. بو اركا سيكا لا سيتي اكس سوا لا سيتي اكس سوا دانا كاين نا اكس بكارينو هردو داني ورقي ورق ابي باساداني ام يا سايب ام كلا سلو دوسي معنا او هر هماشتا كليره ابي باساداني ام يا سايب yeah x must be less than or equal to y okay pick one by one for example 1 and 1 can I say 1 is less than or equal to 1 yes is 1 less than or equal to 1 is yes so it's in here it's in R. How about 1 and 2 can I say 1 is less than or equal to 2 the first one must be less than or equal to the second one okay that's why also. How about 4 and 2 can I say 4 is less than or equal to 2 no as you see we have no that number here we have no that pair in the set R. Set R is the set of relations. That means it's the set of all pairs which satisfy this inequality. We pick any two numbers from X. ليرة واباشترا يك وريان بقدي بتسلسل. سرد هذا كله خوان اللي منتج يعني. هم يباس داني كم بالله. يك ويك دو سير شوش. باشا أنا ماني. إنجا يك ودو باس داني كات بالله. يك وسه باس داني كات يك وشوار باس بالله أنا هم باس داني. إنجا دو لغل سه. زم دو لغل كا باس داني كنا. اگر سر تا دو بنوسم اینجا یک بنوسم پس دای نکه بوله برای دو شکتر نیله شکتر یک خود یکسان نیله یک دو لگل چواره اینجا چی معنی سه و چوار تنها امانه پس دای و تا اگر سر تاش معنی گوره بنوسم دو هر بچو پس دای ام یا سه نه ام relation low this method okay and here that we could find the domain and range by writing down the list of all first members as domain and the second members as the range, but without repeating. Here we have 4 ones. Okay, we have 1 4 times. We just pick once. So both domain and range, as you found here, both equal to X. And here we have on the example. We have 2 sets. X is 2, 3, and 4. Y is 3, 4, 5, 6, and 7. It says define the relation R. R is the relation. It's our relation. From X to Y. Look, it says from X to Y. It's different from to say from Y to X. Okay? Here it says from X to S. That means we must pick all the first elements from set X. And the second elements from set Y. It says XY in the relation. That means R contains all the XY, all the pair of XY. Which XY? Those which satisfy this condition. When we divide Y by X, when we divide, the second one by the first one, we must have 0 remainder. كواتا اگر هاتو جماره دوما ليره XY معناه ونيا كواتا جماره دوم چیه Y اگر جماره دوم من دا باشه جماره یکم کرد ابي هیچ جماره نمیاد. Okay, let's see. Let's say 2 and 3. Let's check if we can write down this in the relation or not. 2 and 3, then 2 and 4, 2 and 5, 2 and 6. Yeah, it's for all. Yeah, for all, they must satisfy that. Yes, this is Y and this is X. We say 3 over 2. Can we divide 3 by 2? No, so it must not be in the relation. How about 2 and 4? Can we divide 4 by 2? Yes, it's 2 and 0 divided. So it's in the relation. How about 2 and 5? No. 2 and 6? Yes, because we can divide 6 by 2 and we get 3. So 2 and 6. How about 2 and 7? No. Then for 3, 3 and 3. Yes, we can divide. 3 by 3 is 1. So we have 3 and 3. How about 3 and 4? No. 3 and 5? No, because you cannot divide 4 and 5 by 3. Then we have 3 and 6. Yes. Because we can divide 6 by 3. Then 3 and 7. Is in? No. How about 4 and 3? 4 and 4, yes. We have 4 and 4. And we have no more elements. So these are the elements of the relation. ببيبي ناسكا تو أو element عنك هل يبجيري بأي ببيبي ناسكا باساداني بناسكا أي باساداني بناسكا نكان ناتو عند the relation. These all are satisfy the condition, and the condition says that y over it, if we divide y by x, we must have no remainder. This is R. So let's find this is the same as we found here. What's the domain and what's the range here? What's the domain? It's 2, 3, and 4. So the domain is 2, 3, and 4. How about the range? 3, 4, 6. Do you have any other number? No. So the range 3, 4, and 6. These are range. These elements are, yeah, these are domain and range. This is representing this relation by using arrow diagram. We have 2 and 4. Look here, we have 2 and 4. That means we have an arrow from 2 to 4, and we have an arrow from 2 to 6. We have an arrow from 3 to 3. As you see here, 2 to 4, 2 to 6, 3 to 3, 3 to 6, and then 4 to 4. We have only these arrows. This is set X, which and this is set Y, because here we have from X to Y. So we must first write down X and then Y. Do you have any question about that? Okay. Now we have directed graph. For the directed graph, we say it's an informative way to picture a relation. When a set is to draw its directed graph, and it's called digraph. Digraph. Here the steps are, we say if R is a relation on a finite set X. Look, when we draw digraph or directed graph, we must have a relation from a set to itself. That means from X to X. We must have no two sets. We say from X to Y. It must be from a set to itself. So the relation on a finite set A, we say draw dots or vertices to represent the elements of it. That means we are going to write down all elements separately, all elements of the set separately. Then, if the element AB is in the relation, then we draw an arrow from A to B. Let's say if you have 1, 2, 3. If you have 1 and 2, that means we are going to draw an arrow from 1 to 2. And if you have an element with itself, for example, A and A. If A and A is in R, we are going to draw an arrow from the number to itself. Okay? And this graph is called digraph. Let's take an example here. Here you have an example. We have a relation on set A. A is A, B, C, and D. And the relation is AA, AB, CD, DC, and BC. First, we should write down all elements of the set. What are the elements of the set? A, B, C, and D. Let's say this is A, this is B, this is C, and this is D. And now we are going to draw the arrows. Here we have A and A. That means we have an arrow from A to itself, from the first to the second. Okay? So we have an arrow from A to itself. A and B. That means we have an arrow from A to B. We always go from first to second. First is A and the second is B. So we have an arrow from A to B. CD. We have an arrow from C to D. And also we have DC. We have an arrow from D to C. We also have an arrow from B to C. This is the diagram for that relation. Okay, let's explain here. It's the same. That's so easy. Here we have on the relation, we have 1, 2, 3, and 4. To sketch the diagram for this relation, we say if this is 1, 2, 3, and 4. 1, 1. That means we have a relation from 1 to itself. This is the relation. 1, 2, from 1 to 2. 2 to 1. Then 2 to itself. 2 to 3. 2 to 4. Okay. 3 to 4. 4 to 1. That's all arrows. And it's done here. Okay. Here in this example, it says, find the relation when the diagram is given. We have given this diagram, and we must find the relation. First, let's write down the set. What's the set? Yeah, A is 1, 2, 3, and 4. We have only these 4 elements. How about the relation? Say R equals, look, 1, it goes to itself. That means we have 1, 1. Then 1 to 3. Then 2. 2 to 3. Okay. 3 to 1. 3 to 2, sorry. And then we have 3 to itself. That means 3 and 3. We also have 4 and 3. This is the relation. That's all. Okay. From a diagram, we can write down the relation and conversion also. Count all the arrows and then write down them. That's all. Okay, let's take a break for 10 minutes. Okay, we now have representing relations using matrices. We can say matrices is a suitable way for representing relations. A matrix is simply a rectangular array of numbers. Sorry. You say if a matrix has n rows and m columns, rows are the horizontal ones and columns are the vertical ones. We call it an n by m matrix. In a matrix M, the number at the intersection of its ith row and jth column is written as MIJ. Aga member ma habit la roy domu column sembia او كاتلن شي M do ستروح حسابك انجا column. To represent a relation as a matrix, we should first label rows with the elements of set A. If we have a relation from A to B, that means we are going to write down the elements of set A. Set A means the first set as the rows, and the columns for set B, which is the second set. And the ordering of the elements is not important. We say if you have A to be A1, A2, A3 up to AN, and also B to be B1, B2 up to BP. That means here we have n rows. We have n rows because here we have n elements in matrix A. We have n elements in matrix A. That means we must have n rows, and we also must have p columns because we have p elements in matrix B. And all the elements of the matrix are either 1 or 0. We say it's either 1 or 0. If we have a relation from AI to BJ, then we put 1 for MIJ and we put 0 otherwise. It will be clear in the example. It's also about that. That's the matrix that I talked about here. As I said, we have n rows and p columns. Look at this example. We have these two sets. A is 1, 3, and 5, and B is 1 and 2. The relation from A to B, is as follows. Here we have 1, 1, 3, 2, and 5, 1. We have only these elements in the relation. To represent this relation as a matrix, what we do? We first should write down the number of rows and columns. How many rows do we have? Number of rows is the same as the number of elements in matrix A. Okay, so how many elements do we have in A? 3. We have now set A. Set. كهذا بيوصل السير رومان أي كم element معناه set بيا do. كهذا بيوصل do column معناه كواتا ليرة شو معناه أميك do set شو أجا set كم رومان هي ياك do set أي كم column معناه ياك do. خوزان matrix شيء ورد عن كتير بيشتغل. Okay. We have 3 rows and 2 columns. Now we are going to write down the elements of matrix A here. We are going to write down all elements of matrix A here and all elements of matrix B here in any order. But should in داني لأن نفري وكو سيتا يخبين سو نفري باشو بيش فزور أسايا element كاين سيتا كارير إنوسي but order إنوسي أسايا but order إنوسي. Here we have 1, 3, 5. And matrix B is 1 and 2. May someone else say 3, 5, and 1? It's okay. It's okay. No problem. Okay, I'm going to just write down the same as the order, what's in the set. 1, 3, and 5. What should we write down in these rectangulars? In these squares, what should we write? We are going to write down either 1 or 0. I can write down either 1 or 0. When do you write down 1? If there is a relation between AI and BJ. AIJ, sorry. AI and BJ. Let me use undercolor. Look, this element represents the relation between 1 and 1. Do we have 1 and 1 in the relation? This is the relation. Do we have 1 and 1? Yes. So you write down 1 here. If we have it in the relation, you write down 1. How about this element represents 1 and 2? Do we have 1 and 2? No, we have no 1 and 2 in the relation. So you write down 0 here. How about this one? 3 and 1. Do you have 3 and 1? No. So you just write down 0. How about 3 and 2? Do you have? Yes. one, yeah. Then 5 and 1. Do you have 5 and 1? Yes. How about 5 and 2? No. We write down 0. So let me clean it. This is 1 and this is 0. What's that? This is the matrix representation of that relation. We just put 0 for those which have no relation, which is not in the relation, and we put 1 for those which are in the relation. That's all. It's so easy. As you see, that's it. You just need to write down the numbers. Okay, even clean the bracket, the squares. Let me write down again. This is 1 0 0 1 1 0. This is the matrix representation of this relation. Here the relation must be given. We just convert to matrix form. So if we have given a matrix form, how do you return it to relate to this form? We will take an example about that. Here we have a relation from set X to Y. X is 1, 2, 3, and 4. Y is A, B, C, and D. This is the relation. What's this? It says write down the matrix, the relation as the matrix form. What's the size of that matrix? 4 by 4. Yeah, it must be 4 by 4. This must be 4 by 4. And we're going to write down the elements of the first set. What's the first set here? It is X. We have X to Y. That means we're going to write down the elements of X for the rows. 1, 2, 3, and 4. And then elements of Y for the columns. Say A, B, C, and D. A, B, C, and D. Then, do we have 1 and A? No, we have no 1 and A. So you write down 0. How about 1 and B? We have it. That's 1. How about 1 and C? We have no 1 and C in the relation in R. So you write down 0. 1 and D, we have it. So you write down. And then 2. 2 with B, with A, with B, with C, with D. And so on. Write down them all. Okay? If you have a relation, if we have, for example, 2 and B, here we have 2 and C in the relation, write down 1. But we have no 2 and B and 2 and A in the relation, write down 0 for these two. And you also have no 2 and D. And then for 3 and 4, write down for all. Here we get this matrix. May someone write down this matrix? And may someone else change the order? May someone else change the order? Look, let's start 2, 3, 4, and 1. D, B, A, C. It's okay. You can change the order of elements in sets in X and Y or A and B. These both are correct. Okay. أتوانيد أوردريس إليمنت كان يسيتك بقول ليه يكود سيو شو أنا نساوا أتواني بشيو كده بري شو عارف سيو يكود فرقين أوردر كيف بقول أساي أوردر تنايك داني بقول غير كم بقول كيشنية ما له يودو أنا فاش بتستولي امتحان بري تاو غلطني راسي أوكي بلام هول با زانا الريليشن كا هي أنا أو تشترك تاو سرتا أسوي ستوني زانت شيء اگر هبو لنا ريليشن كيا يقدر اگر نبو صفر دابلين تا ما شيء يصير بالكلام. Now we have a matrix. We should write down the relation. Okay, what's the relation here? Here is from this set to that one, from X to Y. Says if x divides y, it's the relation. It says the first one should divide the second. That means the second one should be divided by the first one. Catalin, x divides y. Wata x تواني دابش كردني y. Wata y أتواني بسردوا دابش بيت. Okay. Here it's the matrix form. Let's write down the set form of the relation. We say R equals what? Look, we have no 2 and 5, but we have 2 and 6. We have it because it's 1. And then we have 2 and 8, but we have no 2 and 7 because it's 0. But we have 2 and 8 because it's 1. As you see, this is 1. That means 2 and 8. Then we have no 3 and 5 because it's 0. But we have 3 and 6. It's 1. بس أنا كيكن okay? We have no 3 and 8, 7. We also have no 3 and 8 because those are 0. Then do you have 4 and 5? No, we have no that. How about 4 and 6? No. 4 and 7? No. How about 4 and 8? Yes, because that's 1. فنها أواني كيكن جوتر خلاو كيمس. أواني كنانس. شيبو 4 and 8. That's the relation. Okay? It's converting the matrix form to set form. And conversely, we can return to this one. That's easy. So this is how to convert matrix form to set form of a relation. Here we have another example. It says R is a relation on the same set, on set A, and defined as follows. R is AA, BB, CC, DD, BC, CB. To write down the matrix form of this relation, so what's the size of the matrix? Look, it's from A to A. It's from A to A. That means both columns and rows the same. How many elements do you have in A? 4. That means it must be a 4 by 4 matrix. And then let's write down the elements of A for both rows and columns. A, B, C, and D. We also write down A, B, C, and D because it's from A to itself. So both must be A for rows and columns. Do you have AA? Yes. This is one. How about AB? We have no AB in the relation. We have no AB in the relation. So you just put 0. Look, this is AB. It represents this location. How about AC? It represents this location. And so on for others. For AC, we have no AC also. We just put 0 for it. How about AD? We have no at all. Then for the second row, we have B and A. Do you have B and A? No, we have no. Up to now, we just have AA. We have no B and A, so we just put 0. How about BB? Yes, we have BB. Put 1. And then BC. This is BC. B first, the row, and then column. BC. Do you have BC in the relation? This is BC. Yes. That means we should put 1 here. How about BD? We have not. That's 0. And then for C. CA. We have no CA. We have, how about CB? Yes. CC? Yes. Because here you have CB and CC also. How about CD? We have not. Then D. We have no DA. We have no DB. We have no DC, but we have DD. This is the matrix representation of that relation. Okay? تنها أويك هاي جيكو تكان زين شو بوريك جيكو تكان ورد يشوف بزانك شيء دي أيمان هي سرتها سوية كان جستني أجر هم أبو يقدرني أجر نبو صفر. Okay, that's it. This is the matrix representation of the relation. Look, here we have given a set and a relation. It says, what is R represent? That means what's the relation here? We must find the relation mathematically. Okay, this is the relation. The definition of the relation is that, what's the definition of the relation? We must find it. It's 1 and 2, 1 and 3, 1 and 4, 2 and 3, 2 and 4, 3 and 4. So what's the relation? What's the relation between first elements and second elements? These are first elements and these are second elements. What's the relation between these? شوفي عندي هي العنوان جيكوتية كمكان جيكوتي دو مكان. سيرجي همو جيكوتية كمكان بشوف ترى جيكوتي دو مكان. واحد. هميشة جيكوتية. So you say the relation is XY is in R, where if and only if X is less than Y. That's the relation. This is the definition of R. As you see, it says here, what's R represents? R is this. It says Y greater than X. So it's the same as to say X is less than Y. Okay. And here it says what's the matrix for R. Here we have given the relation. This is our relation. You can find the matrix for. That's easy. This is the matrix form. Here we have a relation from A to itself. From A to itself. That means for all elements, for row and column, we're gonna put elements of A. Look, 1, 2, 3, 4, 1, 2, 3, 4. These are elements of A. Do you have 1, 1? No. So you just put 0. And for others, the same. We solved some examples about this. And you have this example. It says, an airline services the 5 cities, C1 up to C4, C5. C1 represents CT1, CT2, CT3, CT4, and CT5. This table below gives the cost in dollars of going from CI to CJ. That means it's the cost of going from a C to another C. Okay, from a C to another C. For example, here from C1 to C2, it's $140. Going from C1 to C2 is 140. How about C2 to C3? It is $200. The cost of going from C2 to C3 is $200. And therefore, this is the question for about that table. It says, if the relation R on the set of cities A to be, here we have 5 cities, so the set is C1, C2, C3, C4, C5. In the set you have 5 elements. CI related to CJ. If and only if the cost of going from CI to CJ is defined and less than or equal $180. وقتها پەیوەندەکەمان كمان چییە؟ پەیوەندەکەمان بریتیە لە چوون لە شارێک بۆ شارێکە بە مەرجێک چوونەکە کەمتر یاخود یەکسان بێت بە $180 کۆستەکە. Okay? Look at the table. Let's return to the table. This is our table. Let's first write down the matrix. So what's the size of the matrix? What's the size of the matrix? We have 5 cities. So it's 5 by 5, is it? It's 5 by 5. because we have 5 elements in matrix A. And now we are going to write down the C's for rows and columns. C1, C2, C3, C4, and C5. Again here also, C1, C2, C3, C4, and C5. Going from C1 to C1 is undefined. So we just put 0 for that. Going from C1 to C2 is 140. Is that less than 180? Yes. So it's 1. Then going from C1 to C3 is 100. Look, the definition. The definition says that it must be less than or equal $180. The cost of going from a C to another C must be less than or equal to 180. So C1 to C3 is 1 because it's less than 180. C1 to C4 is 150. Yes, that's 1. How about C1 to C5? It's 200. Is that less than 180? No. So it's 0. That's for the first row. And then for the second one. C2 and C1. Is that less than or equal to 180? No. So you just put 0 for this one. This is C2 and C1. Then C2, C2, it's undefined. So you just put 0. C2, C3. That's 200. أما اللي صوّرتها كم تلا؟ لا خير. أنا أبيت كوستا كي اللي صوّرتها كم تلا. So you see, it is 0 because that's 200. It's greater than 180. Here, C2 and C4, it's 160. So it's 1. Then C2 and C5, it is 220. It's greater than 180. So it's 0. Then for C3, C3, C1, it's 110. It's less than 180. We put 1. Then C3 and C2, it is 180. Is 180 less than or equal to 180? Yes, that's true. So we put 1. And so on for others. Look, this is the relation. And that's the matrix form. Okay? You can also write down the relation here. It's C1, C2, C1, C3, C1, C4. Look, we just write down for the relation. We just write down C 1, 2, 3, 4, and 5 in the in the sets. We have no C1, C1, but we have C1, C2. C1, C2. This is in the relation. How about C1, C3? Yes. For the matrix form, we just write down either 0 or 1. But for the set form, we should write down the symbols used for cities. These are the elements of the relation. And the above one, which I talked about, just try to finish this one, complete this one. It is the matrix form of the relation. You have in degrees and out degrees. For the in degrees and out degrees, we say in degree in the diagram, you see in degree of a vertex is the number of edges terminating at the vertex. بنوش مالكم هي چند سهمی بو هاتوا چند سهمی چند آروی بو هاتبو جماره آروکان بريتيا لا in degree كان. Okay, that's in degree. اگر چند سهمی لی درچبو او پیوتی out degree. وقت سهمهات وكان جماري سهمهات وكان in degree كان. جماري سهم درس وكان out. Look. Here You have given this example. It says let A to be A, B, C, and D, and R is a relation on set A that has the matrix. This is the matrix form of the relation. It says construct the diagram of R and list in degree and out degrees of all vertices. Let's first write down or construct the diagram. How many elements do we have in A? A, we have A, B, C, and D. We have these 4 elements in matrix A. In set A. To write down the vertices or to complete the diagram, we are going to send to the matrix. Look, we have a relation from A to A because it's 1. Okay, that means we have an arrow from A to itself. Is it? We have an arrow from A to itself because here A is related to A. It's 1. And then for A and B, it's 0. So there is no arrow from A to B. And then for A and C, we have it's 0 also. That means we have no arrow from A to C, and for D as well. Okay. Or you just need to count the ones, not the zeros. Okay. Here you have this one. What does this represent? It represents B and B. Is it? That means we have B and B. Then this one, it is C and A. That means we have an arrow from C to A. Okay, from C to A. And about this one, we have an arrow from C to B. We have an arrow from C to B. And then from C to C, we have an arrow from C to itself. From C to C. Then for D, we have an arrow from D to B. We have an arrow from D to B. It's 1. From D to B. Go through. Then you have an arrow from D to itself. From D to itself. That's it. Then let's write down the in degree and out degree. For in degree and out degree, what we do? We first list the elements of the sets. We should first list the elements of the set. Here we have A, B, C, and D. For in degree of A, how many arrows come to A? How many arrows do you have which comes to A? 2. So it's 2. For B, 3. For C, only 1. Okay. For D, 1. How about out degrees? A is 1. B, 1. C, 3. 1 for itself, 1 for B, 1 for A. D, 2. These are in degrees and out degrees. Okay. For finding the in degrees and out degrees, you should first write down the diagram or construct the diagram, and then it's easy to write down the in degrees and out degrees. And that's it. These are the list of in degree and out degree. We're going to write down the number of arrows for in degree and out degree. You have these exercises. That's for yourselves. I'm going to put these in the assignment also. I'm going to put most of the exercises into the assignment, and I'm gonna try to upload the assignments for you by the end of this week. Yes, assignment 1. You will have 4 assignments during the semester, but you have no quizzes. You just have 2 tests. Test 1 will be in week 5, and test 2 will be later. Okay? I think there's no midterm. There's only 2 tests, and that's all. Okay? The coordinator said that, but I don't know if she changed her mind. I don't know. Okay? She said there is no midterm and there's no quiz, but please try to do the assignments by yourselves. If you do the assignments by yourselves, be sure that you will get a high mark in exams. Okay? assignment كان خوتان بيكن زور باشا لا امتحان شو كهم فكريك يعني. Okay? Even the last year questions will be in the assignments. Okay, so try to do it by yourselves. You can make groups in 5. Okay, you can make groups in 5 students in each group and solve the questions together. Yes, for the assignments. And each group should submit only 1 copy. I mean, one of the group members submitted, that's all. That's enough. But you should write down all of your names on the assignment. Okay? And if you can do it by individual, but no more than 5 students. The groups must not be more than 5 students. You even can do it individually. So you have properties of relation. For the properties of relations, okay, let's see now for today. I'm not going to talk about new topic here.